Okay, logarithmic functions and exponential functions have their applications in physics and chemistry and also in finance. Anybody here not like money? Okay, we got one person doesn't like money. Everybody else does. Okay.
Oh, wait. I meant I don't like money.
You don't like handling money. Got it, got it. So, here's what happens, okay? We have two different types of equations that we use to be able to calculate things that compound over the course of time. For example, I like to take my money, I like to invest it, and I like to know how much I'm going to get back after I've left it in saved for 5 or 10 years. Everybody else with me there? Okay, so all of a sudden, Grandma gives you a gift of $2,000. You're like, I'm going to keep that in savings until I'm 30. How much is it going to be worth then when I'm 30 years old? You want to know that, right? And the bank chooses to compound that interest, say, once a year, say twice a year, say 12 times a year. When banks compound things every so often, we use this formula. However, there are things in nature that compound all of the time. For example, cell phones. They're disgusting, are they not? True or false? There's bacteria sitting on your cell phones, which is why we wash our hands before we eat, which is why we take care of that. Okay? The fact is that do bacteria wait like once a week before they decide to repopulate? No, they're repopulating all of the time, right? And when things repopulate all the time, especially in nature, then we use that formula. I give you these formulas on the test, but you need to know how to use them. Here's the description. The amount of an investment is equal to the principal, which is your initial investment. So I put $2,000 in, and then you multiply it by 1 plus R. R is the rate at which it is being compounded. N is the number of times it's compounded during that time, raised to the NT power, where T is the number of years. Let's try an example together. Let's try number 2. It says $1,500 is invested at an interest rate of 8% per year. So my R value is 0.08. It's $1,500 that's invested, so the principal is $1,500. It's compounded semi-annually. How often is semi-annually? Twice a year. So N is equal to 2. Find the value of the investment after 5, 10, and 15 years. Those are all my T values. So I'm going to show you a couple ways to go about this. There is really, other than making just a silly mistake, there is no excuse for going into the test and not knowing how to do this first part. The amount is equal to P times 1 plus R over N raised to the NT power. That's my formula. It's written down for you. Why am I using this one and not the PERT one that I have on the other side? It's not continuous. It's twice a year. Okay? So the amount is equal to the principal, which is 1,500 times 1 plus 0.08 over 2 raised to the, N is the number of times it's compounded, which is twice. And then T is the number of years, which is 5. 2 times 5 is 10. So raised to the 10th power. Or in other words, 1,500 times 1.04 raised to the 10th power. Notice how 0.08 divided by 2 is 0.04. We've got that. Now I've got to use my calculator for that, right? Okay, so let's see how much that investment's worth. I take out my handy-dandy calculator, and I get this guy, which we don't know about. And I type in second quit, 1,500 times parentheses, 1.04 raised to the 10th power. And I get a grand total of $2,220.37. Any question how I calculated that? Would you like a shortcut for this problem? Okay, so if I want to change it to 10 or 15, all I'm changing is the T value, right? So therefore I have this formula. The amount is equal to the principal, which is 1500, times 1.04 raised to the 2t power. That's a function of the amount with respect to time. So what I can do is go to my calculator, and I can go into y equals, and I can type 1,500 times 1.04, and I raise it to the, see if anybody can catch this, what do I type in? Parentheses 2t. That way it raises both the 2 and the x to the exponent power. Do you see that? So if I now go to my table, I can type in those values that I want. I want to check it 5 years, and notice I have my 2,220. I want to check my 10 years, and I want to check my 15 years. And you have those amounts respectively. Notice how it cuts off the 100th place of your decimal. If you just highlight that number, you can see it all expressed there. So I have $3,286.68. And then I have $4,865.10. So using the table option or your calculator can save you a little bit of time, right? Any question there? Going once? Twice? Yes. So the formula is raised to the nt power. You see that? So it's going to be compounded semi-annually. So n is 2. So we put a 2 in for n. And then t represents the number of years. And that's what we changed.
Oh, okay. Oh.
Better?
Yeah.
Okay. All right. Now I want to show you something cool. This is the y in mathematics. This is my favorite part of mathematics. Look at this formula. Suppose you compound it twice a year. Notice you end up taking that rate and dividing it by 2. That kind of reduces your return, doesn't it? But then you raise it to the 2 power. Well, that increases the rate, doesn't it? So, all of a sudden, let's say we compound it 10 times a year. Well, you're dividing by 10. It's like, ooh, that's hurting my rate. But then you're raising it to that 10th, and that helps your return, doesn't it? See how those are competing forces? The n in the denominator and the n up in the exponent. See how those are competing? Watch what happens if we change that n. And you don't have to type it in, but watch my calculator here. It's super cool. I'm going to take this, and I'm going to take this y equals and type in my 1 plus 1 over n, and I'm going to raise that to the n power. See how we have this x in the denominator and then up in the exponent? Let's see what happens to that. Phoebe, how many times do you want to compound your interest a year?
6.
6 times? I'll first do 1 time. I get 2. I'll do 3 times, and I get that. I do 6 times, and I get that. How many times do you want to compound your interest, Izzy? Just 3? I like this number better. It's bigger, isn't it? How many times? 1,000 times. Let's try 10 first. Then let's try 100. Let's go to Aiden's idea of 1,000. How many times do you want to compound your interest? Who can see where I'm going with this? 50 billion. Let's do it. 50 billion times. What's happening to that number? Anybody recognize that number?
E.
That is E, folks. That is what E comes from, is if you compound something continuously. An infinite number of times. Literally, E is this number, which looks ridiculous. 1 plus 1 over infinity raised to the infinity power is actually equal to E. That's what it is. So, Sam, thank you. Yes.
What is my son's asking this? They said e to the I5 plus 1 equals 0.
Yes, it does. You don't know that that's calculus, and they don't understand it yet either. Radioactive substance decays in such a way that the amount of mass remaining after t days is given by that function where m of t is measured in kilograms. Do you think radioactive substance waits for like, okay, 10 o'clock every day I'm going to decide to decay? Or do you think it decays continuously? It continuously decays. So if you look at the equation in which it decays by, you can see that it has an E in it. Let's answer these questions. Find the initial mass. Initial mass means at what time? If it's like the first thing that happens, where do you think we start at? Time 0. So we're going to say initial mass is at time 0. So I'm going to plug a 0 in for t and see what the initial mass is. So m of 0 is equal to 23 e to the negative 0.0043 times 0. What is negative 0.0043 times 0? 0. What's e to the 0? What's 1 times 23? So 23 kilograms is what you start out with. And I have people get that question wrong on the test. Can you tell me you will not do that? What's that? You could just look at the 23, honestly. The next one, how much of the mass remains after 21 days? What will I do there? See if you can type in 21 correctly into your calculator and get the correct amount. Go ahead, try, go. Okay, folks, eyes up here. Just to be clear, you can access E in 2 ways. If you want to take E to a power, you can press second natural log, and that will automatically place the parentheses so everything up there is in the exponent. Or you can do second E or divide and you grab the E, but then you need to make sure you include the parentheses. I press enter, you should have 21.014 kilograms. Are you okay with that? All right, something that we talk about in chemistry. Have you guys ever talked about half-life? Question. Yeah, so in this situation, we usually use years, but if it's written in days, then just convert everything to days, okay? Allie asked an excellent question. It says that this refers to the number of years. If the problem is written in days, then you could just use days as well. It all depends on how it's written, okay? How many days, after how many days does it have half the initial mass? Well, that's a big question. Because in this time, I'm trying to find time, aren't I? What is half of the initial mass? If the initial mass is 23, what's half of that?
11.5.
So when is 11.5 equal to 23e to the negative 0.0043 t? See, in this problem, it says how many days. It's asking us to find time. So we know the mass. The mass is 11.5. Now, fortunately, you guys are extremely intelligent, so you know how to solve this. What do I do to both sides? Close. First I divide by 23. What is 11.5 divided by 23? So I have 1/2 is equal to e to the negative 0.0043 t. Great. Caitlin, now what do I do to get rid of the e? I natural log both sides. So I'm going to take the natural log here and the natural log there. The natural log of 1/2 is negative 0.693. And on the right-hand side, I now have just negative 0.0043 t. What do I do to solve there? So negative 0.693 divided by negative 0.0043, and I get 161.16 days. No, you press E. You want to press natural log of 1/2. 1/2. Natural log of 1/2.
Oh, it's because I clicked second.
Yep.
So, the 1 day.
It's fine to put the 1/6. I prefer the decimal. Any question on that?
What if we put days or we just put T equals?
That's fine.
You want that, what do you want that to do?
Wait.
It's fine.
I got something here. Oh, never mind. I'm sure that's correct.
Okay, flip it over.
Wait, never mind. I'm not sure. What you gonna say?
We're going to skip problem 3. We're going to do 4, 5, and 6.
Yeah, I got 197.
A man invests $2,000 into an account that compounds annually at an interest rate of 5.5%. What is the amount in the investment after 4 years? Annually is once a year. You go ahead, see if you can use your formula and solve that first part, not the second part, but you should be using A is equal to principal times 1 plus R over N raised to the NT power. Go ahead, see if you can find that and figure that out. Go. Okay, let's see what you got. The amount is equal to the principal, which is 2,000, and you're going to multiply that by 1.055, and you're going to raise it to the 4th power. Did everybody get that formula? Okay, what did you get?
477.
Are we okay with that computation? Okay, that should be straightforward. We can all do that in test. Don't get that problem wrong. Let's go to the one that's a little bit more complicated. It says, how long does it take for the investment to double? Well, what would be double?
4,000.
4,000 is equal to 2,000. Good luck, sir. So I don't have a, n is just 1, so I don't have 2t here or something like that. I just have t. So I need to solve that equation. Fortunately, you guys know how to do this because you did this yesterday, right? What do we do to both sides? If you divide by 2,000, you get 2 is equal to 1.055 raised to the t power. Should I subtract 1.055 from both sides? Should I divide 1.055 for both sides? How do I get rid of a base of 1.055? Log base 1.055. I know that that looks weird, but that's how you get rid of the base of 1.055. So we log base 1.055 of both sides. Notice that those cancel, giving me t. And then on the left-hand side, how is it that I compute log base 1.055 of 2? Log 2 divided by log of 1.055. Some of you might have an actual change of base operation on your calculator. I don't. So I've got 12.95. So it take 12, almost 13 years for this to double in value. Okay? No, I prefer the decimal. All right, 2 more. Investment of $800 was compounded quarterly over the course of 6 years. The initial investment resulted in $1,245.83. What was the interest rate? I want you to talk to your peer next to you and talk about these variables I have right there. Which ones do we know and which one do we not know? Talk. Go. All right, you should have $1,245.83 is equal to the principal, which is 800 times 1 plus R over 4 raised to what power? 24th power. So you don't know R. N is equal to 4. The number of years is 6. So it's 24 times it gets compounded. So there we have it. I want to solve for R. How do you solve for R? Divide by 800. Take out my calculator. 124, 5.83 divided by 800. And I get 1.55728. 1.55728 is equal to 1 plus r over 4 raised to the 24th power. So, what do I get rid of? Do I get rid of the 1, the 4, or the 24? What do I have to get rid of now? Got to get rid of the 24. How do I get rid of the power of 24? Nope. The 24th root. If it was this thing squared, you would take the square root of both sides. It's the 24th power, so we have to take the 24th root of both sides. Which seems ridiculous because you've never done it before, but this is exactly where you use that. So I know that on the right side, I'm left with 1 plus r over 4, but on the left side, I got to take that to the 24th root. And that's 1.55728. And how I do is I raise it to the 24th root is 1 over 24 power. That's how I do it. And I get 1.0186. Now what? Subtract 1. 0.0186 is equal to r over 4. Yeah, you go ahead. Tell them I said aye. If you're asking for Bitcoin, don't sell.
Sell.
0.0744 is equal to r. I should write it in a percent. What percent would that be? 7.44%. How's that? You got a question? You got a question? Okay. Okay, so Hannah asks, can you take the 24th root a different way? And you can. You go 24 and you press math and you grab number 5. So that means you're taking the 24th root of 1.55728. So that's another way to do it. Okay? Those are your operations. Last one, population rabbits. Modeled by that thing, where P is in thousands, is the number of rabbits at time T since the population was tracked. Find the population. We're going to find the initial population. We're going to find the population at time is equal to 10. And then we're going to answer the last question. So let's understand what this means all together. Suppose that I plug in a number and I get P equals 2. Does that mean I have 2 rabbits? That means I have 2,000 rabbits, okay? Because it's measured in thousands. Everybody understand that piece? Okay? All right. So let's find the initial. Initial population means I plug in what? 0 for what? T. So 1 plus 5e, and what is negative 0.3 times 0? 0. So notice that's our equation. What's e to the 0? 1. 5 times 1 plus 1. 30 divided by 6. 5. So I have 5 rabbits to start with. 5,000 rabbits to start with. Everybody okay with that?
Do we have to write it like that even though they're asking?
We have to state 5,000. Okay? So if I want to know the number of rabbits at time 10, what would you do? Plug 10 in for T. Go ahead and see if you can figure out the number of rabbits at time 10 right now. Okay, some people struggle to plug that in and see what you can get. Go. Well, it's negative 0.3 times 10. I did, and so 10 times negative 0.3 is negative 3. Sure, just 3 decimal places is fine. No, that's fine. You get round, or you can go to just cut it off after 3. Either one's fine. All right, this is what you should have typed in your calculator. 30 divided by parentheses, because you want to divide by everything in the denominator. 1 plus 5e to the negative 3 power. And so if you type that in, you get 20. So I got 24 rabbits. 24,020.45. 20,020.45. I know you guys are wondering, what about the 0.45? Do we have a mutant rabbit? Do we have a rabbit that got hit by the lawnmower? I don't know. Sorry, 24,000. I was thinking too much about the joke I was trying to make. Hardly anybody laughed at it. Which...
So what if we just wrote 24 rabbits?
24 rabbits, I would take a half point off on the test. There's 24,020 rabbits. You got to put parentheses around that bottom part. Okay? Yep. All right, last one.
Wait, I got 24,000.
You got 24,021?
Wait. Yeah.
Must have just typed something in.
Yeah, I did. E to the negative
Yeah.
third.
That's fine. That's fine. You just rounded. It's okay. Yep, that's fine. All right, last one. Find the population after 10 years, which we did, and find how many years it takes for the population to reach 8,000. So look at this. I know that it starts at time equals 0 at 5,000, and then at time equals 10, it's at 24. So if I'm wondering when it has a population of 8,000, it should be between what 2 years? 0 and 10. So let's figure that out. When does it have a population of 8,000? So I say 8,000. Very good. Exactly. 8 is equal to 30 over 1 plus 5e to the negative 0.3t. This was similar to a question you had on your assignment from yesterday. How would you go about solving that? Eight over 1, now what? Cross multiply. 30 times 1 is 30. 8 times 1 is 8. 8 times 5 is 40. Now what? Minus 8, I get 22 is equal to 40 e to the negative 0.3t. Divide by 40. 22 divided by 40 is 0.55. What do you want to do now, Paige? Now we want a natural log both sides. Take out my calculator. Natural log of 0.55, and I get negative 0.5978 is equal to negative 0.3t. Divide by negative 0.3, and we get 1.99. So at 1.992 years, that's when the population hits 8,000. And that fits, it's between the 0 and the 10 that we thought. That is the last problem that you have from this unit. We have a very special day today. Today is none other than Tony's birthday. Everybody stand on your chairs. Tony, come on up. Chair of cheer, chair of cheer, chair of